This is a video demonstration for my individual design project. This is my clock slash indicator. It's a low frequency clock and manual indexer. It utilizes 3 555 timers, 2 logic ICs, and an inverter, a CMOS inverter. The first 555 is being used in the astable mode, which is generating a user adjustable square wave. It's adjustable between 0.3 and 3.6 hertz, so very low frequency. The target and desired range of this is 0.5 hertz and 1 hertz. Being adjustable gives some variation to the duty cycle, but with the potentiometer in series with the second resistor, it provides an approximate 50% duty cycle across the range. It ranges between 45% and 49%. So for the purpose of this circuit, that's close enough. The second 555 is being used in the monostable mode to provide a user-directed impulse. It's a short burst to provide a circuit being tested with a single rising edge, where the clock is essentially that provides a repeatable, steady, time invariant square wave pulse. Selection between the two modes is done utilizing a 555 in a non-standard configuration, and that is utilizing the internal SR latch in the 555 as a flip-flop. So flip it one way, you have astable mode as indicated by the output LED, which right now is approximately half a hertz, as demonstrated on the Tektronix 2232 clean square wave with 0.53 hertz. Now if we switch it over to astable mode, we get a clean rising edge, a clean impulse when the manual switch is selected. Selection between the two is utilized by the 555 flip-flop. When it is selected one direction, the outputs for both astable and monostable are put into the inputs of separate AND gates utilizing this IC right here. The second input for each of those is provided by the flip-flop. For one mode of operation, we have the standard, the direct input from the flip-flop. I believe that's on, yes, for the astable. We have the input from the astable, and then we have input straight out from the flip-flop. For the bistable, or monostable, input goes in, and then we have the input for the flip-flop being inverted, so when the flip-flop goes low, the CMOS inverter flips it to high, so it passes the high output of the monostable. And this last IC is just OR gate, which allows the outputs for both those AND gates to be combined into a single output. For use in a circuit, this is designed to be used with to drive digital circuits like those built in Introduction to Digital Design that is taken sophomore year. And the normal output would just be a wire connecting to whatever circuit requires the impulse, a clean impulse, or a clean clock signal.